Imagine this. You're eating, breathing, charging your phone, driving your car, and all of it is only possible because 150 million kilometers away, a star is burning non-stop. That star is the sun, and it's not just a bright dot in the sky. It's the engine that powers all of Earth. When you bite into an apple, you're actually consuming sunlight stored in glucose molecules. Plants capture photons through photosynthesis and convert them into biomass. Animals eat those plants, and we eat animals or plants. Either way, the energy you get came from the sun. Even if you're eating a greasy burger with cheese and bacon, it's all sunlight, processed through grass, grain, cows, chickens, and millions of years of evolutionary food chains. The sun feeds us even if we don't realize it. But that's just the beginning. And by the way, stick around to the very end, because we'll answer one of the most unsettling questions in all of science. What happens if the sun suddenly dies? The truth might surprise you. Every tree that grows, every field of wheat that waves in the wind, every vine that stretches toward the light, all of them are solar-powered factories. Through photosynthesis, plants absorb carbon dioxide and water, and with the help of sunlight, turn them into sugars and oxygen. This is the fundamental source of the food chain. In the Amazon rainforest, billions of leaves are absorbing photons every second, converting light into energy and matter. Each blade of grass in your local park, each apple on a tree, every tomato in your salad, they're all pieces of bottled sunlight. Consider this. The energy stored in just one apple is the result of thousands of hours of accumulated sunlight. The tree that produced it grew for years, absorbing and storing the sun's power. Multiply that by every edible plant on Earth, and you'll understand that agriculture is nothing more than controlled solar energy capture. And when animals eat those plants, they simply transfer that energy up the chain. Cows graze on grass, converting cellulose and plant matter into fat and protein. Chickens peck at seeds, grains, and insects, converting them into eggs and meat. Even fish, feeding on algae or other fish, are participating in a solar-fueled cycle. Humans, with our varied diets, are just sophisticated consumers of repackaged sunlight. Even processed foods, chips, bread, soda, trace their calories back to fields of corn, wheat, or sugarcane, which all depend on sunlight. The sugar in candy, solar-powered. The caffeine in coffee, brewed by sun-grown beans. The oil in your salad dressing, extracted from sun-nurtured olives or sunflowers. And it's not just food. The cotton in your clothes, grown under the sun. The wood in your furniture, from trees that drank in solar rays for decades. Even biofuels, marketed as green energy, are simply liquid sunlight. Think of fossil fuels. Oil, coal, and natural gas are not exceptions. They're ancient sunlight, trapped over millions of years. Prehistoric plants, rich in carbon from photosynthesis, were buried, compressed, and transformed into energy-dense fuels. When we burn gasoline in a car or coal in a power plant, we're releasing solar energy stored eons ago. Every calorie burned in your muscles, every heartbeat, every neuron firing in your brain. It all traces back to the sun. You are solar-powered. Your thoughts, your actions, your very life is sustained by a continuous stream of photons that left the sun 8 minutes ago and now strike Earth with a force of over 1,300 watts per square meter. This energy is relentless. Even when clouds obscure the sky or night blankets the land, the sun continues its cycle, radiating power outward across space. It is the great battery of the biosphere, the original and ultimate source. The next time you eat a piece of fruit, fuel your car, or simply take a breath, remember, you're interacting with light that once danced on the surface of a star. Water flows, clouds drift, winds howl, and storms rage. All of it choreographed by a single force, sunlight. Let's start with the most basic idea. Why does water move at all? Because the sun heats it unevenly. The sun's rays warm the Earth's surface, but not equally. Oceans absorb heat differently than land. The equator receives more direct sunlight than the poles. Mountains block wind and redirect heat. All of this creates temperature gradients, and those gradients make water move. When sunlight strikes the ocean, it causes the upper layers of water to evaporate. This invisible vapor rises into the atmosphere, carrying latent heat energy with it. As it rises and cools, water vapor condenses into clouds. And when those clouds get heavy enough, it rains. Every drop of rain, every snowflake, every misty morning fog, all of it began with a photon of sunlight. Rivers are born from this dance. Rain falls on mountaintops, feeds into streams, and flows downhill under gravity. Without constant solar input, there would be no rain. And without rain, no rivers. Lakes would dry, aquifers would not recharge, and the entire water cycle would collapse. The sun is the prime mover of this entire cycle. It's what drives the hydrological engine of our planet. Let's zoom out. The sun doesn't just move water. It shapes climate zones. Deserts like the Sahara exist because of where the sun's heat concentrates. Heating air at the equator causes it to rise, cool, and descend at subtropical latitudes, creating arid regions. Tropical rainforests form where warm, moist air rises rapidly and dumps rainfall daily, again powered by relentless solar energy. Storms? Hurricanes? Typhoons? All of them feed on warm ocean surfaces, charged by sunlight. The heat of the ocean is their fuel. Remove the sun, and they would vanish. Ocean currents, like the Gulf Stream or the Pacific's Kuroshio Current, are also driven in large part by solar heating and Earth's rotation. These currents moderate temperatures, carry nutrients, and even influence weather patterns continents away. Think about it. A photon leaving the sun can end up becoming a drop of rain that nourishes a tree, cools your skin, or becomes part of the river that powers a dam. And speaking of dams, hydroelectric power is sunlight in disguise. Water flows downhill due to gravity, but it got up the mountain because the sun lifted it there, through evaporation and precipitation. Every spinning turbine in a hydro plant is an echo of solar input. Even snow and glaciers, what we often think of as cold, lifeless elements, are shaped by solar cycles. Snowpack melts when spring sun returns. Rivers surge with meltwater. Floods, agriculture, and ecosystems depend on these solar-driven rhythms. And the climate? Our entire atmosphere circulates because of how sunlight is distributed. Trade winds, jet streams, monsoons, they're all patterns of motion triggered by thermal inequalities, created by how much sunlight hits which part of Earth. The Earth's tilt? It gives us seasons. Summer and winter exist because of the angle at which sunlight strikes. Long days, short days, all of it is clocked to the rhythms of solar input. Without the sun, the atmosphere would freeze and collapse. The seas would stop moving. Clouds would disappear. Earth would become a static dead rock. So when you watch a river flow or listen to rain tapping on the window, know this: you're witnessing sunlight in liquid form. When you feel a breeze against your skin, you're not just sensing air in motion, you're experiencing the sun's power made tangible. Wind is sunlight, redistributed. It is the result of uneven solar heating on the Earth's surface. When sunlight warms one region more than another, it creates differences in air pressure, which in turn cause air to flow, from high-pressure zones to low-pressure ones. This is the birth of wind. At the equator, the sun heats the surface most intensely. Warm air rises and cooler air rushes in to replace it. This movement is then deflected by Earth's rotation, creating trade winds, westerlies, and polar easterlies. Vast atmospheric conveyor belts powered by the sun. Jet streams, powerful air currents high in the atmosphere, also owe their speed and direction to solar heating patterns. These winds can exceed 280 km/h and influence weather systems around the globe. Mountains and valleys? They channel wind, not randomly, but based on how sunlight heats terrain differently at different times of day. Even local breezes at the beach, like the familiar daytime sea breeze, are born when land heats up faster than water, causing air to rise over land and pull in cooler ocean air. At night, the reverse happens. All of it a result of the sun's rhythm. But sunlight doesn't just move air. It spins turbines. Wind turbines convert kinetic energy from moving air into electricity. The faster the wind, the more power generated. And that wind, remember, started as sunlight hitting the Earth unevenly. A single large wind turbine can power thousands of homes, all thanks to photons that hit the planet hours before. In countries like Denmark and parts of the US, wind accounts for significant portions of energy production. Offshore wind farms now harvest air currents that never rest, driven endlessly by the sun's heating of the ocean. But it's not just about electricity. Wind is part of the climate system, distributing moisture, heat, seeds, dust, even nutrients. For millennia, humans used wind to sail ships, mill grain, and pump water, long before the electric grid. And all of that power came not from coal or gas, but from the sun's whisper across the land. Even tornadoes and cyclones, while terrifying, are nature's chaotic expression of solar-powered systems. Remove the sun and wind dies with it. Atmospheric circulation, turbulence, gusts over deserts, the breath of the jet stream. It's all a vast moving ocean of gas stirred by sunlight. In this sense, when you see a wind turbine spin, you're not watching metal move air. You're watching the sun reach down and flick a switch. When we think of solar energy, we often picture gleaming panels on rooftops, silently converting sunlight into electricity. But long before humans mastered photovoltaics, the sun was already storing its power underground, in the form of fossil fuels: oil, coal, natural gas. These are not mysterious magical substances. They are the remains of ancient life, fueled by solar energy, buried, compressed, and transformed by time. Let's go back, way back. Hundreds of millions of years ago, Earth was covered in lush swamps, dense forests, and shallow seas teeming with microscopic plankton. These plants and organisms captured sunlight through photosynthesis, just like plants do today. But when they died, they didn't decompose fully. In places where oxygen was scarce, like swamp bottoms or seabeds, the organic material piled up, layer upon layer compressed under sediment, heat, and pressure. Over millions of years, these layers were chemically altered. Plant matter became peat, then lignite, then bituminous coal, and eventually anthracite. All of it essentially carbon-rich sunlight trapped in solid form. Tiny marine organisms, plankton and algae, transformed into petroleum and natural gas hidden beneath Earth's crust. That's right. When we pump oil or shovel coal, we are harvesting solar energy from prehistoric times. Every flame that burns in a gas stove, every engine that roars on gasoline, every light powered by a coal-fired plant is running on ancient sunlight. This explains the staggering energy density of fossil fuels. They're not just decayed plants, they are compressed time. Millions of years of solar input, pressurized into a few grams of material. But there's a twist. Fossil fuels are finite. They take eons to form, but we can burn through them in minutes. A process that began in the Carboniferous period can vanish in a few hours inside a power plant. And there's a cost. When we burn these fuels, we release the carbon those ancient organisms absorbed. Carbon that had been safely locked away underground is now returning to the atmosphere as carbon dioxide. This is how burning ancient sunlight leads to modern climate change. The same sun that gave us energy also holds us accountable. Still, fossil fuels powered the Industrial Revolution. They launched the electric age, enabled global transportation, and shaped modern civilization. Without them, humanity's progress would have been slower, or perhaps impossible. But we now understand the source. Every plastic bottle, every jet plane, every light bulb powered by fossil fuels, it all began with sunlight that once fell on prehistoric ferns and floating plankton. So when you drive a car or turn on a light, you're not just using energy. You're unleashing photons that left the sun hundreds of millions of years ago. Before cities, before oceans teemed with fish, before even plants rooted into soil, there was light. The sun did not just warm the earth. It built it, molecule by molecule. One of the most powerful processes on our planet is also one of the most ancient, photosynthesis. This is the process by which plants, algae, and some bacteria convert sunlight, carbon dioxide, and water into glucose, a sugar, and oxygen. At the heart of this reaction is chlorophyll, a green pigment found in plant cells. It absorbs sunlight and uses that energy to split water molecules into hydrogen and oxygen. The hydrogen is used to build sugars. The oxygen is released into the air. That's right. The oxygen you're breathing right now, every single breath, is a gift from photosynthesis, and therefore a gift from the sun. Roughly 3.5 billion years ago, the earliest photosynthetic organisms, likely cyanobacteria, began pumping oxygen into the oceans and atmosphere. At first, this oxygen oxidized iron in the oceans. Then, over millions of years, it began to accumulate in the atmosphere. This led to what scientists call the Great Oxygenation Event, around 2.4 billion years ago, a pivotal moment in Earth's history. Before that, Earth's atmosphere had almost no free oxygen. But thanks to sunlight-driven photosynthesis, Earth became a planet rich with breathable air, enabling the rise of complex life. Every tree, every blade of grass, every patch of algae in the ocean is part of this massive solar-powered oxygen factory. And it doesn't stop there. Sunlight also triggers vitamin D production in your skin. It regulates circadian rhythms, the body's internal clock. It's wired into your very biology. Plants, animals, fungi, all life forms are entangled in a web spun by the sun. DNA itself, the molecule of life, exists because earlier organisms adapted to solar conditions. The bases of DNA and RNA absorb UV light, a trait that may have helped early life avoid damage and evolve repair mechanisms. Even evolution is guided by light. Mutations often arise due to UV exposure. Over time, these tiny shifts in DNA led to the vast biodiversity we see today. Without the sun, life would not only vanish, it could never have existed to begin with. And the photosynthesis story continues today. Plants grow toward light. Animals follow food. Ecosystems organize around access to solar input. Coral reefs thrive where sunlight penetrates water. Forest canopies form to maximize photon capture. It's all a dance of energy. So next time you walk through a forest, swim in the ocean, or even look in the mirror, remember this. You are the result of a 4 billion-year relationship between life and the sun. Let's imagine a terrifying scenario. The sun suddenly disappears. No explosion. No supernova. Just gone. What would happen to Earth? The first 8 minutes? Nothing. Light takes that long to travel from the sun to us. For 480 seconds, life would go on as normal. But then darkness. The sky turns black, even at noon. The moon vanishes. Stars shine brilliantly against a backdrop of cosmic silence. No sunrise ever comes again. But darkness is only the beginning. Temperatures would plummet. Within a week, the average global surface temperature would fall below 0 degrees. Oceans near the surface would begin to freeze. Within a year, Earth would be 73 degrees. In a few more, 2 to 40 degrees, just a few degrees above absolute zero. Only geothermal vents and underground bunkers would offer temporary refuge. Photosynthesis would stop instantly. Plants would die within days. Herbivores would starve soon after. Carnivores, not long after that. The food chain collapses like a house of cards. Electric grids, still powered briefly by nuclear, hydro, or stored energy, would soon fail. Civilization as we know it would be over. Gravitational chaos begins. Earth orbits the sun at 30 kilometers. With the sun gone, it would drift off in a straight line into space, like a tethered ball suddenly cut loose. Other planets would do the same. The solar system would unravel. The oceans would freeze, but not all the way through. Below the icy surface, insulated by the ice itself, water could remain liquid for thousands or even millions of years, warmed by Earth's core. Some microbial life might persist there, just as it does today near hydrothermal vents in the deep sea. But make no mistake, Earth would be a cold, dark, lifeless rock drifting through interstellar space. Now imagine the opposite, a sun that grows too hot. In billions of years as it ages, the sun will expand into a red giant. Oceans will boil. The atmosphere will evaporate. Earth may be engulfed entirely. The sun gives, but one day it will also take away. Until then, it remains our guardian star, a nuclear furnace providing warmth, light, energy, and time itself. Every clock, every heartbeat, every harvest, every memory depends on it. Without the sun, Earth would never have been born. And without it, we won't survive. Cherish the star above. It is the beating heart of everything you know.